How are reptile lungs similar to bird lungs? If you've ever wondered how reptiles and birds breathe and whether there are any similarities between their lungs, you're about to find out some fascinating facts. First, let's talk about the basic structure of lungs in both groups. Reptiles, including lizards, snakes, and crocodiles, have lungs that are quite different from those of mammals but share some interesting similarities with bird lungs. One key similarity is the presence of unidirectional airflow in some reptiles. Just like birds, certain reptiles such as iguanas, monitor lizards, and crocodiles have lungs where air flows in one direction, even when they are inhaling or exhaling. This is different from mammals, where air flows in and out in a tidal fashion. In birds, this unidirectional airflow is facilitated by air sacs scattered throughout their bodies. While reptiles don't have these extrapulmonary air sacs, some reptiles do have a similar mechanism within their lungs. For example, the lungs of monitor lizards and crocodiles have main airways that branch off into many perforated sac-like tubes called parabronchi. Air travels through these tubes in one direction, without backtracking whether the animal is inhaling or exhaling. Another similarity is in the efficiency of gas exchange. Both bird and some reptile lungs are designed to maximize oxygen intake. In birds, the air sacs help in continuously extracting oxygen from fresh air. Similarly, reptiles like monitor lizards have high rates of oxygen consumption, which is supported by their unique lung structure that combines unidirectional and tidal breathing. The skeletal support around the lungs is also noteworthy. In birds, the lung cavities are furrowed, which helps in maintaining the one-way airflow. Similarly, some dinosaurs and reptiles have vertebrae that jut into the lung cavity, a feature more similar to birds than to other reptiles like crocodilians. In summary, while reptile lungs are not identical to bird lungs, they share some significant similarities, particularly in the mechanism of unidirectional airflow and the efficiency of gas exchange. These similarities highlight the evolutionary connections between these groups and help us understand how different animals adapt to their environments in unique yet efficient ways.